So let me move on from here. So we've talked about the different orders, and the orders, remember, refer to the exponents on top here. So let me just erase this for a second. Right? If I said this was an order 1, I'm talking about the exponent that's here, the exponent that's here, the exponent that's here. This number tells you what the exponent. What is the actual 0 itself? It's what makes the thing in the bracket become 0. So x plus 2 set equal to 0 means it's minus 2. That's the actual 0. Okay, let's move on. Let's move on. Again, all of these handouts are on the Math Video Library, and then the video will be available for viewing later on. So when we're graphing these functions, right, we can come up with tables like this one here, which help us to analyze what's going on. I'm going to leave the symmetry part of it for now. And I'm actually going to, in the interest of time, I just spent a lot of time just sort of sorting out some of the tech issues a while ago. I'm actually going to just go straight to the first graph of the function here. And it says the least possible degree and assign a leading coefficient. Okay, so look at this function. It obviously has 3 zeros. Hopefully that's obvious. Has 3 zeros. So when it says what's the least possible degree of the function, the sign a leading coefficient, just count the number of zeros, because you cannot have a degree, excuse me, which is less than the number of zeros. So the least that this could be would be a degree 3. So let me put that down. So it's a degree 3, third degree. That's the least. It could be higher. It could be maybe 5 or 7 or so on. But it's at least a third because it has 3 zeros. Third degree. How about the sign of the leading coefficient? Looking at that function, can we tell the end behavior? Anybody? I'm not asking anybody in particular. I'm not spinning the wheel. I'm just asking. Can we just look at the function and determine the end behavior of this function? Right? Look at how it's traveling. Right? If it goes on forever in this direction and goes on forever in this direction, what would you consider to be, okay, so I'm seeing Q2 to Q4. Okay, good, excellent. So this would be Q2 to Q4. So what would be the sign of the leading coefficient in this case? Is this a positive or is this a negative? Okay, I'm agreeing with negative. The x-intercepts and the factors of the function. That's the next part of this. What we're ultimately trying to do is get the equation of this line, right? So the x-intercepts would be here, here, and here. Those are my x-intercepts. So from that, are we able to come up with a reasonable equation using those as factors? So y equals, now we know it's probably going to be a negative something or the other, but what are we going to put as those factors, right? What would you suggest we put as the factors of this function based on those zeros? Look at those zeros. What makes sense for the factors? There's a 0 at -5, there's a 0 at 0, there's a 0 at 3. Give me some factors that would make sense in this case. Give me at least one of the factors, just one. Let's do one at a time. Give me one factor that makes sense. So x plus 5, well done, to the -5. Okay, can you give me another one? X plus 5, perfect. X minus 3. And then the last one would be what? Just simply x. Good. Call it x minus 0 if you like, but what's the point of saying minus 0? It's simply just x. Now, is this enough for us to say that this is the function? Right? We actually could look at one other thing, which is to find a point that's on the line. It's not easy to find any point on the line, so what we probably should do is just put an A in the front for now, because we're saying that we're not exactly 100% sure yet, unless we can read one of the points precisely, right? And it does seem as if well, maybe there's, actually, you know what? Let's use this as one of the points on the line, right here. Minus 230 seems like it's a point on the line. Minus 30, rather. Seems like it's a point on the line, right? Let's see if maybe we can figure out what the A is. The A is probably going to be negative. In fact, let me erase this for now. We don't know what the A is. Let's just call it A for now. But like what we just did a few minutes ago, can we not come up with that A if we know that one point that's on the line is minus 230? Let's assume that that is correct, by the way. All right? Can we not use that to figure out what that A is? Yes, Emily says, and yes, Joel says. So we're going to do exactly that. So we're going to put the minus 30 is equal to A. We don't know what the A is yet. And anywhere we see X, we're going to put minus 2. So minus 2 plus 5, minus 2 minus 3, and minus 2. Okay? We might actually be able to come up with the equation of this function. So let's continue. I'm going to move the graph down a bit. I think I can do that. Oh, the whole thing is moving down. That's not good. All right, so that didn't work. So let me see if I can fit it in under here. So minus 30 is equal to the A times, this looks like 3, this looks like minus 5, and this is still minus 2. So 5 times 3 is minus 15. 5 times minus, sorry, 3 times minus 15, minus 15 times minus 30. So minus 30 is equal to 30A. So therefore, I know this is looking crowded. Therefore, A is equal to minus 1. So thank you, Joel. So we actually have the equation. The equation is what we had up there before. Here's the equation. We'll get to the positive negative part in a little while. The equation is y equals minus the x plus 5 to the power of 1. Right? So it's an order 1, 0 times x minus 3 times x. Right? We actually could get the equation. All these are order 1 zeros, and that makes sense because they're all going straight through the function. Right? They're going straight through the line. They're not bouncing as it is when it's an even order 0. It's just going straight through. So that makes sense, and that equation seems to square with what we expected the A to be. We expected the A to be negative, and it in fact was negative. Now, I'm going to move this whole thing down because we have to answer. That's not what I meant to do. I want to move this whole thing down. Here we go. The other thing we need to talk about is, where is this function positive and where is this function negative? All right, so let's look at the picture. So very carefully at the picture. We start off for where it's positive. What I mean by where it's positive is, where is the graph above? And this is where those brackets that we talked about in the very first class yesterday are going to come in handy when we're describing an interval. What part of this function is the graph above the x-axis? Well, I'll answer that for you for this one. So I'm going to give you the answer for this one. Anywhere to the left of minus 5, it's above the x-axis. The red line is above the x-axis, and that means it's positive. So the first answer for that is, oh, come on, Mr. Kamak. So the first answer for that is anywhere from minus infinity up to minus 5. Union with, that's not the only place, anywhere from 0 to 3. That's where the graph is above the x-axis, right? Anywhere from minus infinity, right? Anywhere from to the left of minus 5, so that's where minus infinity is, until you get to minus 5, at which point it stops being positive. And then it gets positive again anywhere from 0 up to 3, and after which it's no longer positive. Where is the graph negative? It's the opposite. It's negative when it's below the x-axis. So anywhere between minus 5 and 0 is where it's negative. So from minus 5 to 0 is negative, along with, can anybody help me to tell me where else you think it is going to be negative? Right? I have one more part of the graph where it's negative. Can you help me with that, please? Anybody? There's one more part where the graph drops below the x-axis. Do you know where that is? From 3 to infinity. Thank you very much, Harish. And how do I write that? 3 to infinity. Notice that I have round brackets everywhere. There's a good reason for that. Why am I not including, for instance, let's go back and look at where it's negative again. Why am I not including the -5 and the 0 for where it's negative? Why am I only including everything that's between them, but not including the -5 and the 0? Remember, when you have a round bracket, it doesn't include the boundaries. Does anybody know why I'm not including -5 and not including 0? Why is that not part of my answer? It's only that's in between them, but not actually at -5 and not actually at 0. Remember, I'm asking where it's negative, right? Where is it negative? So is -5, at -5, is the graph negative? No, it's at 0. At 0, it's at 0. So it means that it's not negative, because to be negative, you have to be below the x-axis. But when you're actually at -5, you're at 0. 0 is neither positive nor negative. It has to be below. That's right, Keonti. Has to be below. That's a good answer. Okay. One more, and we'll stop. One more. Look at this graph. What is the least possible degree of this graph? Now, notice that it has some bouncing zeros on this one, right? Can I go back for a second? Noah's asking. I sure can. Remember, you're going to have the video later on, though. I just keep reminding you of that, right? You can always pause the video at any point so that you can look at something for a little bit longer. Just for the negative answers. Okay. So -5 to 0. That union sign means I'm adding it to 3 to infinity. Okay, great. All right, let's try this one very quickly. All right, I'm going to skip the first part of this question, which is the least possible degree. I'll just get to the second part. X-intercepts and the factors of the function. So let's get the factors. All right, I'll show you the graph in just a second. Can anybody give me any of the factors for this function? Any of the factors. So x plus 2 is 1. Okay, I agree. So x plus 2. Any other factor? Let me bring it back down for you. Another factor would be x minus 1 and x minus 3. Good. And that just looks at what the zeros are. The zeros are 1 and 3 gives me the x minus 1, x minus 3. So let's put y equals a again. Now, should I put 1 on all of those brackets? Or what kind of exponents do you think belongs on those brackets? Should they all be 1, or should some of them be 2, or maybe 3, or 4, or 5? What do you think, folks? Is there... So there's a 2 on the x minus 3. So put a 2 here, sounds like you're saying. All right. Does everybody agree with that, by the way? How about the x minus 1? Does that get a 1 or 2? What would you say for the least possible degree? All right, Noah, I'm glad you're asking that. But let's address that tomorrow, okay? We just quickly see if we can come up with the equation here, and then we'll address that tomorrow. Could you explain how we got the 2 for x minus 3? Okay, Joel, thanks for the question. Look at how that 0 is different from the other 2 zeros. There's a 0 at -1, there's a 0 at 1. But the 1 at 3 is different. Can you tell me how it's different, Joel? Can you think of any reason why that 0 at 3 is different from the other 2? Do you see any difference there? Tell me if you see a difference in the few minutes and a half that we have. You have no idea? All right, I'm going to circle them, all right, because I really want you to try this. Would you agree those are all zeros, Joel? Would you agree they're all zeros? They're all x-intercepts? Yeah, okay. Isn't there some difference between the one that's at -1? I'm going to color code them again. I should have color coded them. Isn't there some difference between the 2 that are black and the one that is red? Oh, okay. So let's see. So 3 to 1, 3. Not so much that. What I'm trying to get you to see here, Joel, is that the one at 3 is bouncing on the x-axis. It doesn't go through it, right? It doesn't actually cross the x-axis. It just bounces and goes back in the same direction. Whereas the zeros that are at -2 and the zeros that are at 1, those two zeros, the graph is actually cutting through and continuing through to the other side. Do we get the homework for today? No, I was saying I was going to give you a break today. So there is homework for today, but please make sure, I'm going to repeat this, that you complete the online quiz that I gave you yesterday, and also that you did the homework from last night. All right, so I will say that. I'm not giving you any new homework today. I know you're disappointed, Brooklyn. I'm sorry to Brooklyn. I'm sorry that I'm letting you down by not giving you homework, but I'll make it up to you and everybody else. Okay? I'm just kidding. I'm just kidding. But anyway, I'm only asking you to make sure you finish those two other assignments, the homework from last night and the online quiz. And I've given you links to both of those in the calendar for yesterday. So especially if you weren't here, Caleb and whoever else wasn't here yesterday, I think who else was that? I think Brooklyn was absent yesterday as well. So yeah, so please make sure you get those done. All right. So look, folks, it's 12:34. I think maybe I should leave it there. We should be able to actually solve this by using maybe this y-intercept here to get the value of the a. By the way, what's the degree of this function? Can anybody answer that question quickly? All right. Anybody know what the degree of this function is likely to be? Is it a first, second, third, fourth, fifth degree? What do you think, folks? It's a degree 4. Thank you, Noah. You're right. We'll come back to this tomorrow. All right. You all have a great weekend. And these videos will be posted on the calendar later on. All right, you take care. See you on Monday. Monday, of course, is in the afternoon. Bye for now. Thank you.